My name is Nevena Nikolić, and I'm a program manager in SQL Managed Instance team based in Belgrade in Microsoft Development Center of Serbia. And I mostly work on performance issues and performance tuning in SQL MI. So I'll be talking about performance role today. Basically, you all know that performance troubleshooting is not an easy task. So today I'll share some tips that you can that can help you to identify what causes the performance differences when migrating, and some guidelines that can help you to improve performance of your workload. I'll try to cover the most important tips for performance comparison, performance tuning, and performance monitoring. One of the most common tasks when migrating to MI is I'm sorry, I'm losing. I hear myself double. So what I said, one of the most common tasks when migrating to MI is a comparison of workload performance between the source and the destination instance. To successfully compare those performances, you should consider the following three steps. The first one, compare the environment settings on your source and your target instance, such as number of cores, memory, compatibility levels, etc. This is important so that the comparison is as reliable as possible. And we know we're comparing apples. We're like comparing apples to apples. The second step is to create performance baseline on the source server, noting down the max and average CPU usage, performance of the critical queries, etc. And the final step is to monitor the performance on the target MI and compare it with the baselines from the second step. So now we'll dive into these three steps one by one. As said, the first thing you need to do is to ensure that the characteristics of your source are comparable with the destination MI. The most important factors for comparison are number of vCores and number of cores if we're talking about SQL on-prem. Also amount of memory and IO characteristics. Other factors that might cause different performance of the instances are different server and database properties, such as compatibility levels, max DOP, cardinality estimator, encryption, etc. Different trace flag settings, or different TempDB settings, such as the number of files for TempDB and whether the TempDB is encrypted or not. So you may try to do this manually, but it might be hard to notice the difference between two environments because we need to cross-compare many different views and properties. So I put here some public scripts that can help you to compare environment settings more easily between your source instance and the target MI. I'll show you now that I'll show you how you can use this. So basically, I have these two instances. On my right-hand side is VM, is a virtual machine, SQL VM, and on my left-hand side there is an MI or managed instance. So I said I'm here at get properties script. And yeah, what I actually wanted to tell you all is that I'll share all those scripts with you afterwards and also the presentation. So you can go through this on your own at your own pace. Okay, so first, what we should run this get properties script, and it will create an XML result in this form. I will do the same for actually I did the same for the VM, and my XML is here. Now we have another script that's called compare properties. If we go there, we only have to fill in these two missing things. One XML of for the source and one XML for the target. So basically, here's XML here. is the target one, because this is MI. And I'm pasting it here. Going back to this one, I'm selecting from here and pasting here. It's just as simple as that. Now I should run this script, and I'm getting something like this. So this may vary, independence of your source and target instances, obviously, but we can conclude many things from here. For example, compatibility levels, they are different. Max DOPs, different. Also, one of the main things, and that's the core count, it's also different. So you should, okay, I'm gonna just go back to the presentation now. What I want to say is that you should bear in mind that these scripts will not tell you why there is a difference in performance or why some different setting impact the performance. So you would need to look at the comparison results yourself. But the main value of this script is the fact that it enables you to easily get a list of environment differences without cross-comparing individual settings using, a bunch of DMVs. So what you should note is that you don't need to take some immediate actions whenever you see some difference. And you should not assume that all of the differences listed here can cause the performance issues. So if possible, try to modify the settings on your managed instance to match your source instance or server in order to make a fair comparison. And if it's not possible, just keep in mind these differences for later investigations. Here I place some other tips for you to play with afterwards. I'm not going to go through all of them just for the sake of time. Now we're going to the second step. To compare the performance of your workload on MI with your workload on your source, you need to create a performance baseline that will be used later for comparison. So basically, a performance baseline is a set of parameters that define your average workload on your source. So it's like a set of representative parameters. If you notice any issue with your workload on your source, such as high CPU usage, constant memory pressure, TMDB, or parameterization issues, you should try to resolve them all before taking the baseline and migration. Because if you try to migrate known issues to any new system, you might cause unexpected results and invalidate any performance comparison later. So what you should do, you should select a set of queries that are important to your business workload and that are representative of your workload. You should run those and measure and document minimum, maximum, average duration and CPU usage for the queries, and performance metrics of performance metrics on the source server overall, containing all of this CPU usage, IO latency, throughput, IOPS, I don't know. Page life expectancy, we'll talk about that later as well. Size of TMDB, etc. Okay, so the following sources can help you create the performance baseline. And we'll go through them quickly. I'm just going to share again my two SMS windows. And now, for example, to monitor CPU usage, you can use this performance dashboard, because SSMS provides easy-to-use reports where you can monitor usage of various system parameters. And this performance dashboard is one of the useful reports that you can use to monitor CPU usage. How you can get to it once you connect to your SQL Server or Azure SQL instance, you can select reports and go to performance dashboard straight away. Or if you're interested in top queries that are consuming your CPU, top queries sorted by the total CPU time, you can also use this dashboard to get them. Also, another way to do so. Okay, maybe this is better for the visibility of yours. If you go to any of the databases, you can go to this query store, and this is enabled for each SQL Server 2016 plus. On MI, obviously, it's enabled by default. It's available by default because MI is the latest and greatest, and it's currently in a SQL 19. So, query store, and here we may find top resource consuming queries, so we can watch them from here as well. I'm not going to go into details again. I'm saying this just for the sake of time, but you can investigate all of this with the scripts and with the resources I'm gonna provide you after the presentation. So also let me go back to the presentation. We should monitor memory usage and determine the amount of memory used by different components, such as the buffer pool, plan cache, column store pool, in-memory OLTP, etc. In addition, you should find average and peak values of the page life expectancy memory performance counter. Also, you should monitor disk IO usage on the source SQL Server instance using these DMVs. And I'll actually do a demo of this a bit later. But finally, what I want to say is that as an outcome of this activity, you should document the average and peak values for CPU, memory, and IO usage on your source system, as well as the average and max duration and CPU usage of the dominant and the most critical queries in your workload, so that we can keep track on them later. Also, if possible, take the actual execution plans of the most critical queries. That will be useful later, because these values we'll use to compare with the performance of your workload on the managed instance. And finally, the third step, compare performance with the baseline. You should monitor the performance of your target MI, and you should compare it with the baselines from the previous step. When you do that, you may get three possible outcomes. The first one is our happy scenario. So workload performance on the managed instance is aligned or better than the performance on the source. In this case, you confirm that migration is successful. The second possible outcome is that the most performance parameters and queries in the workload perform as expected, with some expectations resulting in degraded performance. While the third outcome, you may get that most of the queries are slower on the target instance. So the second and third cases require some further actions and investigations, as well as different approaches. So we'll discuss them in the following slides. Let's start from the worst and the most challenging scenario, and that's when the performance of the most queries is degraded. When this is the case, you need to change something in your database or the managed instance. So do not try to analyze and correct individual queries, because there is probably some global setting that will fix most of them. First, check for the underlying issues that may cause the performance problems. And here are some scripts that you can use. You can check tuning recommendations view, or open the query store, the top regressed queries. You're accessing that the same as I already shown you. So to So you're doing this to see if there are some SQL query plan regressions. You can also run some community tools to identify the potential issues, such as a lot of plan compilations, query plans with timeouts, a lot of virtual log files, etc. So what you should do is try to use different and multiple tools if possible, because any tool might help you to discover some potential issue. We are also recommending to always enable automatic tuning or force last good plan on your managed instance. And if you're using general purpose managed instance, make sure that you apply best practices to optimize storage. We'll dive into this later. All in all, try to resolve as much as possible issues before continuing the investigation and rerunning performance tests. Okay, so now if you're sure that you're comparing apples to apples and that there are not hidden issues either on MI or SQL Server or SQL VM or whatever the source is side, check the CPU usage both on source and the target. I already talked about the performance dashboard, reports, and query store in SSMS, but you can also. Okay, I'm sorry. Am I getting? Okay. Sorry, I thought I'm getting a message from you, but I don't see the Teams. So, yeah, let me continue. Where is it? Yeah. Okay. So I've talked about those two. But you can also track CPU usage in Azure portal, or you can use those DMVs to monitor CPU usage on managed instance. Also, you can use some custom scripts and open source libraries like this query performance insight library that enables you to query CPU usage. And let me open my SMS again so that we can quickly run through this. So basically here the DMVs I mentioned. Here's that QPI library that I installed. It's an open source library, and I'll share the link. I'm sharing the link in presentation, so you'll have access to it. Okay, so basically when I run this, I get something like this. This is good because this library also enables you to get information about historical CPU usage per query store intervals. So what we should mention is that this QPI library is basically using information from the query store, which is again enabled from a SQL Server 2016 plus. So bear that in mind. Okay. I'm getting nothing here, unfortunately. That's because I don't have any queries running, and I don't have an active workload on this on those instances. Why? Because I chose I chose to make all these runs and all these demos as quick as possible to have time to go through them all. Okay. Going back to the presentation. Sorry. I would say that we should note here that sometimes it's important to correlate differences from the first step with the findings in the following sections. The increase of CPU usage might be expected if you see things like encryption in the environment differences, because encryption uses additional CPU to encrypt the pages. So try to find the correlation of the all findings you are getting. Now, managed instance, as you know, managed instance is using specific RAM to core ratios, and this might not match your SQL Server environment memory. However, this may not be the key factor for the performance difference. You should check if there is difference in memory usage and not total amount of memory. One of the most common wrong metrics that you can monitor is whether the memory instance uses 100% of available memory. Some people believe that this is an issue, so like hitting 100% of CPU usage, but this is expected and desired behavior. Managed instance should use as much as possible memory to cache the pages from disk into the buffer pool. The only case where you will not see near 100% of usage of memory is the case where you have the database is much smaller than the available memory size, so all of them can fit into the memory. Instead, the better metric for memory usage monitoring is page life expectancy performance counter. Okay, opening this again. So I have some queries here ready for you. So for example, let's execute this one. We are getting this memory usage here. We are getting this value. We see this is much greater than this. If we run this a couple of more times and we are constantly getting that MI is getting much less value than VM, that indicates that you should upscale your instance. We could know this from the beginning because this is 8-week course instance and this is 16-week course. But okay, just to confirm that if this is the case, try to upscale your instance. Okay, going back to here to learn more. Here are some resources on the bottom of the slide. And now we are going to the weight statistics. Weight statistics in managed instance are easy way to troubleshoot performance differences because they are telling you why the database engine is waiting for some resources instead of executing the workload. So there are several types of those weight statistics that you can analyze. Global or instance level weight statistics that show you what are the global statistics that are holding up your workload. Here's the DMV you can use to analyze these statistics. Also, there are session level weight statistics and there are query level weight statistics that show why individual queries are rating. To make the analysis easier, I'm using a free open source library, QPI again. And this library has the predefined views that join all necessary query store views to fetch the information. In addition, it takes the snapshots of the weight statistics. And again, it enables you to see weight statistics in the past. So for things you need to do is to take a snapshot on the weight statistics or at least to reset them. And this is the query you should use to reset the weighting statistics. While your workload is running, you can read the weight statistics values. And okay, let me show you this as well. This is going fast, so I can. Okay, if I go to weight statistics, for instance, and I say, okay, read the weight statistics, I'm getting something like this. If I don't know what is some weight statistic, I can simply follow the URL in this info column and go to the SQL Skill site, or just follow this link, which is at SQL Skill site, to find out the more details. The category of weight statistics is very important actually, because if you want to find the queries affected by the weight type, you need to use the category information to identify the queries that wait for this category. For instance, okay, other disk IO, I already had that, so I'm getting this selected. Here I didn't have a bunch of those, so you didn't actually see how useful this might be. But in a real life, like when you're using a complex, when you have complex workload running on this instance, you might find this really useful. Okay, getting back here. This is what I mentioned. Here's the link for access. And we can continue. We are coming to I/O performance. So one of the probably most important metrics that you need to measure and monitor is I/O performance characteristics. In most of the cases, performance of your database depends on the speed of underlying storage and the files where the data is stored. So measuring the file performance and comparing performance characteristics between your source and target instances might be tricky and requires some better knowledge of SQL Server system objects and views. For instance, to analyze your file latency, you should take the snapshots of your I/O virtual file stats. You should calculate the values such as I/O throughput, latency, etc. You should go back in the past and examine the latency of the previous snapshots. And you must be aware that this DME returns cumulative values. This should be sampled. And you would need to calculate the differences between two periods in times. And if you want to extract any useful information from this subject, you should read the following articles, etc. So there is another tip that I'm sharing with you here, and that's, again, using a QPI library. I mean, this is how you can shortcut all the thinking from the previous slide. So first, you need to take a snapshot of the current values using this command, and this is the baseline for I/O statistics, and you can get the cumulative or average values until this point. Now you need to keep your workload running until the moment where you want to measure I/O performance using the following views: the QPI file stats or DB file stats if you are interested in the current database. And let me again run this quickly so I can tell you performance. Okay, so here we only see that it has one data file, one log file size. But if you take a look at the metrics in the top row, you can see read latency MS, and you can see read dial latency MS. So these two represent average latency to complete request end to end, and this with I/O in its names, in their names, they represent average latency to complete request in I/O subsystem. So ideally, these two should be the same, but yeah, I mean, here they are pretty much the same. But if there is a difference, if you find a difference there, then the SQL Server database engine cannot catch up procession of I/O requests, or it introduces some I/O throttling. So just be aware of that as well. Also, okay, what I could also run, for instance, is that, as I said, you can get the file statistics from some point in a time. And here's the example. Don't look at the numbers. As I said, there is no active workload running. But okay, what you should note here is that if you're using general purpose service tier and you see a longer latency, you might try to increase the size of the file that has high latency. because IO throughput of the files in general purpose tier depend on the file size. So with bigger files, you're getting more IO resources and you can improve performance of your workload. Also, what you should note is that the increase of the file size will only work if this is the actual bottleneck. So you should confirm that this is a bottleneck. If you haven't seen write log or page ILH weight statistics in the previous step when we talked about weight stats, then increasing the file size might not help. Okay, finally, we came to plan comparison. If the environment settings are similar and there is no significant difference in weight or IO stats, it is time to investigate the SQL query plans that might be causing the issues. You should also do this part if you notice that there is some dominant weight statistics or CPU usage difference, and if you identify the queries that are causing these differences. So when you identify the queries and you are running differently on your source and target instances, the first thing you need to verify is whether the execution plans are the same. So if the plans are the same, then probably you are hitting some limits, or there is some background job that is eating your resources while your workload is running. If the plans are different, that might be the cause of the change in performance, and you should investigate why they are different. So it's very important to investigate this difference in plans, and if needed, you should force different plan or apply some query hint on your target instance. Okay, I'm just gonna quickly show you how we do this very quickly. Okay, let's see. Run this. What of this? Okay, so here we have two same queries that are running on the same databases. So let's run. And yeah, I'm setting this execution plan to be included. So I'm executing this. The execution plan is running there. Now I'll be executing it here. And this is set. Okay. Okay, so we can see it took 2 seconds here and 18 seconds on MI. So if we go to the execution plans, first of all, we can see there is a difference. So we can see here is parallelism introduced, here is not. But if we wanna compare them easier, so if you don't have an eye for catching those things that easy, you can compare it this way. So let me save this execution plan. I'm just gonna call it that for this purpose. And let's do compare show plans. If I say compare and I'm just using the one I created, okay, I'm getting something like this. So I have those things that are matching, and it's much easier for me now to follow what's going on here, where are the differences. Okay, so another thing is this are those planes here, and I may see, okay, number of executions. Do I see, okay, parallel, true, false? Okay, I see there is parallelism, there is no. I can also look up for degrees of parallelism. So, for instance, if we go here, I can see the degree of parallelism was 1. And if I go here, I can, I can see, that, okay, see, obviously, that the degree of parallelism, I'm not sure why this is, okay, whatever, but you can see it. A degree of parallelism is 8 here. So, what we can conclude from here is that we actually, even though we had this max DOP set to 8, we should introduce some hint here to force it to be actually 8. So do something like this. We can use this and introduce it here and see if anything, if that helped. If you remember, this was 18 seconds earlier, and now it's only 5 seconds. So obviously we tuned this, and we can continue tuning this and searching for differences. So I'm going to cut it here and continue with the presentation. So here are some tips for you to approach this issue, and I'll skip them now. This is for you to have it written like and documented somewhere. And finally, you should check if there is some additional workload that is affecting performance, and wait until any background job finishes to continue the performance test in order to get the reliable results. Or you should implement similar backup process on SQL Server instance to guarantee similar reliability. You should also check for the scripts that are, rebuilding indexes or loading data. It might also impact the performance. In addition, automatic backups on MI use some resources that may impact performance. And it should be noted that in some cases you cannot avoid background jobs. For example, what I stated here is if you have a managed instance with 100 databases, which is maximum at this point, you will always have some backup running in the background because all of them must be backed up in 5 to 10 minutes. Okay, now we are going to case 2. Performance of the some query is different. In this case, you know that performance of the workload is fine with some exceptions where performance of the couple of queries is degraded. In this case, you should try to fix these queries because you have most of your workload tuned. So try to identify why the queries are slower before making some changes. And here's some, some hints. You should you should check on the instance log rate limits. In most cases, you will. In most cases, you will see that you're hitting those. Or there is also an instance level limit on the max log write throughput. Just look at this table here that I put on the slide. So you may not be able to reach the max file throughput on the log file because you're hitting the instance throughput limit before that. So first you need to take a snapshot of your current file statistics, and this is how, you can check upon it. And if you're getting the values that are close to the limit, then you're hitting the instance log limit cap. Unfortunately, limit on the log rate is the price that must be taken to always ensure that the backups are taken. However, we can split the approach here in respect to different tiers. For BC, you may increase number of cores to get better performance, while for the GP tier, there is a whole another story. And it's here. In MIGP, every database file is placed on separate premium Azure Premium disk. You see the disks here in the table, max sizes, their IOPS and throughput. And in some cases, you might experience performance issues because your data files are small and they don't get enough IOPS or bandwidth. So in these cases, you can easily fix the performance issues by increasing the data file size. And here are the tips how to do that. which you may investigate on your own, but here are all useful links to take care of this. And also, what I would recommend is to perform these settings before you start the comparison. Okay, so we already talked about this. Basically, for plan comparison, the goal is to force the database engine to produce the same good plan as on your older version of instance, or as on your source instance, better to say. And if the plans are the same, you should check if the query plan uses more resources on your managed instance and investigate that. Here I listed just some of the key causes of the performance difference. I'm not going to go in details about them. I will be sharing the resources and the links you can read about it. So, simpler bulk recovery model, the drawback of the full recovery model that all MIs are using by default is that it generates more log data than the simple bulk log recovery model, meaning that DML transaction processing in the full recovery model will be slower. Also, resource governance, AJ configuration, automated backup schedule, connection the app to database proximity, TD or encryption, database engine settings, and hardware environment specification that we already mentioned. Also, what I wanted to tell you here as like a Christmas present is that TMDB customization is coming soon. So very soon, in the beginning of the next year, you'll be able to customize your TMDB. Or in other words, you'll be able to set the number of files and their increasement, their properties that will be persisted upon the failover or reset of the instance. Okay, with this, I'll be closing this presentation. And my final words are just to consider the following when comparing performance. Settings should match between source and target. Storage in GP should be configured according to the best practices. There are key environment differences that are like the feature gaps that I listed at the end. And query store and automatic tuning should be enabled on your SQL managed instance, as they help you measure workload performance and also help you automatically mitigate the potential performance issues. So thank you everybody for listening. I'm here for any questions. Also, you can reach out to me afterwards, and I'll be sharing these resources with you.
Great. Thank you, Nevena, for great presentation. Sure. So, do we have any questions? Imamo li nekih pitanja za Nevenu? Pošto nisam primetio da je bilo šta upisano u Q&A prozor, ima li neko ko želi možda da se uključi glasom i da postavi pitanje?
Ja se izvinjam što sam ostavila 1 minut za pitanje.
Nema problema, sve okej. Dobro, ti ćeš na raspolaganju posle, eto, u chat prozoru, naravno, ukoliko se neko bude kasnije setio i bude hteo da postavi neko pitanje. Ukoliko sada nema, ja bih se, evo, Neveni, još jednom zahvalio na odličnoj prezentaciji i naravno pozvao bih sve ostale da pošaljete svoje pitanja kasnije. U međuvremenu, sada ću podeliti ponovo slajd, tu je naš QR kod, tu je anketa koju vas molimo da popunite i naravno učestvovat ćete u nagradnoj igri. Hvala puno, Nevena, još jednom hvala i vama koji ste slušali ovo predavanje. Nastavit ćemo dalje sa programom, sa našom poslednjom sesijom za ovogodišnju sinergiju u 15 časova i 30 minuta. Hvala vam lepo. Hvala, Nevena, još jednom.